All right, today we are diving deep into building the ultimate automated workflow. We're talking about going from a developer's very first line of code all the way to a running, healthy application inside a Kubernetes cluster. It's a journey, for sure, into the heart of modern DevOps, and we're going to see how to pull it off smoothly and securely.
But hang on, before we get into the tech, let me ask you a question. It's a really critical one for anyone who's responsible for production systems. Are you 100% certain that what's live in your cluster right now is an exact copy of what's in your Git repo? Or could there have been a manual tweak, a quick hotfix that never got checked in? This gap, this little difference we call configuration drift, it's a total nightmare. It leads to surprises, failed deployments, and just general chaos.
So how in the world do we fix this? Well, the answer is a pretty big shift in thinking called GitOps. And it's so important to get this. GitOps isn't just another tool you install. Nope, it's a whole new way of looking at how you manage your entire system.
At its core, the idea behind GitOps is actually super simple, but unbelievably powerful. It says that your Git repository is the one and only source of truth. Everything, and I mean everything, that defines your environment, your Kubernetes manifests, your Helm charts, all your application configs, it all has to live in Git. If it's not in Git, it has no business being in your cluster. End of story.
And this slide really shows the fundamental shift. See, in the old way of doing CI/CD, the pipeline is an active pusher. It builds your code, it gets the credentials to your cluster, and it literally forces the change into production. The GitOps model completely flips that on its head. Now there's an agent living inside the cluster, and its job is to watch the Git repo. When it sees a change, it reaches out and pulls that change in. So the responsibility for the actual deployment moves from some external pipeline to an internal agent. It sounds subtle, but trust me, it's a massive deal for security and reliability.
And hey, this isn't just some abstract theory, right? There's some seriously powerful tools out there that make this whole thing a reality. You've got major players like Flux and JenkinsX, but for this explainer, we're going to focus on one of the most popular and, frankly, most powerful of the bunch, Argo CD.
I want you to think of Argo CD as the guardian of your cluster. Seriously, it's the agent sitting right there inside your Kubernetes environment, and its one and only job is to make absolutely sure that your cluster state is a perfect mirror of the desired state you've defined back in your Git repository. So how does this guardian even know when you've made a change? Well, it's got two main ways of finding out. The fastest method is a webhook. The very instant you push a commit, Git sends a little notification straight to Argo CD, which then jumps into action. But hey, even if you don't set up a webhook, Argo CD is always watching. By default, it just pulls your repository every 3 minutes, constantly asking, anything new? Anything new?
And this is where things get truly magical. This quote from the source material just perfectly captures the single most powerful feature of Argo CD. What happens if someone, maybe in a panic, gets access to the cluster and manually scales a deployment? This is what we call self-healing. Because Argo CD is always watching, it will immediately notice that the live state, let's say 5 replicas of a service, doesn't match the desired state in Git, which says there should only be 1. It sees that drift and goes, nope, that's not right, and immediately corrects it, scaling the deployment right back down. It is relentless about enforcing the source of truth, which makes your cluster incredibly resistant to human error. It's a game changer.
Okay, so we've established Argo CD is an amazing deployment engine, right? It makes sure our cluster always matches our Git repo. But that brings up a really important question. How do the changes get into that Git repo to begin with? Who's actually building the new container image when a dev pushes some code? And who's updating the YAML file to tell Kubernetes to use that new image? And that brings us to the other half of the whole equation, continuous integration, or CI. This is the whole build and prepare part of the process, and it's where a platform like Azure DevOps comes in as the perfect partner for Argo CD.
Because look, as soon as you start doing this stuff at a real production scale, you run into some tough challenges. You absolutely cannot check passwords into your code. If you've got 10 microservices sitting in one big repository, you don't want to rebuild all 10 every time one of them changes. And you definitely don't want to be copying and pasting the same build logic for your dev, staging, and prod pipelines. That's just a recipe for disaster.
So let's take a look at how a professional CI system like Azure DevOps gives us some really elegant solutions for all these problems. How we handle secrets, deal with monorepos, and stop repeating ourselves. Okay, first up, secrets.
The golden rule is they never ever touch your repository. So what do? Well, Azure DevOps solves this with something called variable groups, which you can link directly to Azure Key Vault. Your pipeline just references a variable, maybe database password, and when it runs, Azure DevOps securely grabs the latest version of that secret from the Key Vault and injects it right into the build. It's secure, it's auditable, and it's totally separate from your code. It's the right way to do it.
So what about that copy and paste problem? The solution here is templates. Instead of defining all your build, test, and scan logic 3 separate times, you define it just once in a reusable YAML template. Then, your pipeline for the dev environment calls that template and just passes in the dev-specific details. The prod pipeline, it calls the exact same template but passes in the prod details. You update the logic in one file and it's instantly fixed everywhere. It's clean, it's maintainable, and it cuts down on so many potential errors.
And for that monorepo headache, Azure Pipelines has this awesome feature called Path Triggers. You can actually set up the pipeline for, say, microservice A to only run if a change happens inside the /microservice A folder. If someone changes something in the microservice B folder, it won't trigger it at all. This means you're only building what's actually changed, which saves a massive amount of time and computer resources.
So we've seen both sides of the coin now, right? We have Azure DevOps for a super robust CI process, and we have Argo CD for a self-healing continuous deployment. Now, let's put it all together and see this whole beautiful, harmonious system in action.
Let's walk through the whole thing from start to finish. It all begins with a developer pushing code. That action triggers our Azure pipeline, which handles the whole CI piece, building, testing, creating that container image. Now, here comes the critical handoff. The very last thing the Azure pipeline does isn't deploy. No. It just makes one small commit to our other Git repository, the configuration repo. All it does is update the image tag in a YAML file, and its job is done. Almost instantly, Argo CD, our cluster guardian, detects that tiny change. It pulls down the new manifest and applies it to the cluster, bringing the cluster into its new desired state. It is a beautiful, decoupled, fully automated workflow.
And all of this brings us to one last thought. When your entire deployment process becomes this automated, this reliable, this self-healing, it frees up your engineers from all the tedious work of manual deployments and late-night firefighting. It lets them focus on bigger, more important things, improving platform reliability, optimizing performance, building the next generation of tools. So the real question isn't just about how we automate, but what we choose to do with all the time and stability we gain.